So yeah, welcome to the first technical workshop of the Chainlink Hackathon. This builds upon the launch event that we had on Thursday last week. If you were not able to make it, there's no worries at all. I'll be posting a few links here in chat that just include some links to the to watch the summary there online, as well as just some information on the hackathon. If you still have not registered or kind of want to book a call with me, everything is there into the kind of the hacker pack that I'll also be sharing with everyone. And just as a reminder, this event, like all of them, is going to be recorded and posted online within the next 24 hours after it ends. So if you want to go back and rewatch anything or anything like that, you're more than welcome to go ahead and check it out. And if you do have any questions, let's go ahead and put them here in chat. And Richard will be able to get them answered here throughout the session. So yeah, and just introduce the speaker. This is Richard, developer advocate from Chainlink Labs. He spoke at one of the Chainlink Educate sessions. And if you want to go back and rewatch those, they were really good. I'll throw some links to the summaries in chat as well, just so you have them there on your end too. But without further ado, Richard, feel free to take it away.
Yeah, thank you. Appreciate it. And I'll start by saying, ask questions in the chat. I'll do my best to answer them. Or if you want to like raise a hand, I don't know if that's something we can do and like actually ask a question too, like interactivity. Huge fan of it. So yeah, we're going to talk about Chainlink and what is Chainlink. And I don't know, this will be fun. We'll do some demos. I'll try to keep the demos at a pace where if you'd like to play along and follow along, you can. Just as a heads up, you will need some flavor of testnet ETH. Probably Rinkeby is the best bet right now, but also like Polygon Mumbai would work, something like that. Just as a heads up. So let me share my screen and get going. Probably useful to share screens. So yes, I am Richard, one of the developer advocates at Chainlink Labs. My Twitter is there, r.gottleber. Reach out if you have questions. My DMs are open. I love talking to people, answering questions, helping out where I can. If you prefer email, it's there as well. And today, let's talk about what is Chainlink. So the first thing to know before we get into Chainlink is what are smart contracts? What's the purpose of a smart contract? And given this audience, you probably already know, but just to make sure we're all on the same page, smart contracts are giving us the ability to have agreements that are transparent and decentralized. And I think those are the two like biggest parts of smart contracts, in my mind, at least, for why they're so important. If we look back in time, we used to only have contracts where there had to be kind of a third party involved if there was any sort of disagreement or anything like that when it came to contracts. You'd have somebody who would kind of manage that in-between area. And I don't know, I live in the United States, and things here from a legal system side of things, they work most of the time. They're pretty good. But that pretty good still kind of sticks in my craw a little bit because, that means that they sometimes don't work out the way they should. And that disappears when we get to smart contracts. So we have this like super awesome ability to know what is the actual terms of the contract. We can read it, we can see it, other people can verify it, and we know that it's going to execute the way it's supposed to, and there's no third party involved. So the control goes from a third party to the user. The transparency is built in, and it's kind of creating this world of truth-based transactions instead of trust-based transactions. That's huge, right? But there is a slight problem. But before we get to that problem, I have a really hard question for everybody. And if you can put it in the chat, I'd really appreciate an answer to this. Who here can tell me what 1 + 1 is? Okay, I see a lot of people that we're getting it too. Fantastic. So 1 + 1 is a deterministic value. We can all agree that, oh man, I don't know about these two. When it comes to deterministic values, they're things that can be agreed upon, right? If you run the equation 1 + 1, it's always going to be 2. It doesn't matter who runs that equation. It doesn't matter where you are. It doesn't matter when you are. All of those are going to be the same. So we can reach what's called consensus. And blockchains, this is how they work, right? We have all these different nodes and they're basically checking each other's work. And so they need to be able to run the equation and come to consensus. Now, if I ask a question like, what's the temperature outside right now? Well, here in Texas, it's like 90 something degrees and like a bajillion% humidity. And where you are, it's probably going to be different. I answered that question too in Fahrenheit. You might answer Celsius, right? Like these are all, it depends. Another example is if I say, hey, everybody pick a random number. It was 742, right? No, coming to consensus is difficult with things like that. They're not deterministic. Blockchains have a massive problem when it comes to non-deterministic data because you can't check each other's work in the same fashion, right? If I say, pick a number randomly and your number is not the same as mine, we can't check each other's work to make sure it's doing what it's supposed to. That is a massive limiting factor when it comes to blockchains. And smart contracts then as well are limited by this. They're kind of confined into just living on a blockchain because the outside world is messy and the outside world is where this non-deterministic data comes from. And in my mind, I like to think of smart contracts as Genie from Aladdin, phenomenal cosmic power, itty bitty living space. And that kind of bubble around them is the problem. And it's often referred to as the Oracle problem, right? You have blockchains, smart contracts, and they are disconnected from real world data and events. So all this awesome power can't talk to the real world, can't get real world data in because we can't reach consensus. This is where oracles and distributed oracle networks like Chainlink come in. They fill that gap, right? So we have this gap in the middle here where there's this disconnect, and oracles fill that gap. Now, you could totally make your own oracle, right? You could set up a server at your house. On your laptop, you could set up an oracle that would go out and like query an API, get something like weather data, for example, and feed that into a smart contract. It would work, but you would end up kind of short-circuiting around one of the major benefits of blockchains, and that's the decentralization of them, right? If you have a decentralized network that relies on a centralized node, you've effectively undecentralized, you've centralized your network then, right? Because if that one node goes down, well, you're out of luck. If that one node is malicious and providing data that's not really accurate, you're out of luck, right? There's all the benefits of decentralization disappear when you centralize. And so that's one of the problems with creating your own Oracle node. And Chainlink has a distributed Oracle network, which means essentially they run similarly to a blockchain network where there is a network of Oracle nodes that all kind of work together to reach consensus. Now, we talked earlier about how non-deterministic data is difficult to reach consensus on, right? So how do we approach that? We'll take something like the price of an asset. So on the left here, you can see the Chainlink Oracle nodes, and they're all reporting kind of different prices for the price of an asset, right? You have some saying $400, some saying $398. How are you going to reach consensus? Well, the way that Chainlink approaches this is each Oracle node submits their value to the smart contract. And then within the smart contract, there is a function that will come to a trusted answer based upon all those individual reported answers. So we're taking a plethora of different answers and centralizing them on one value. And the way that we do that is with the median for prices, for example, right? That way you kind of get like the most common middle number. This allows us to create hybrid smart contracts, which take that genie out of the lamp. And now we have full access and full power to real world data. You can, pull in information from payment systems or weather data, or basically anything with an API. Any data that you can get, you can bring onto the blockchain now. with a solution like this. So before we go any further, what questions do you all have about understanding the Oracle problem, what Chainlink is, just from like a high level, anything like that? So you want to see a full stack workflow. Are you talking about like all the different kind of products within the Chainlink ecosystem, or I'm not sure what you mean by that? Can Chainlink do the consensus and report the final value to the smart contract? So yes, and we'll take a look at this a little bit more when we get into data feeds. But yes, essentially what happens is the different oracles report their value. That information is stored on chain. And then based on the information that's on chain, you can reach consensus based upon that. So, you know, if all the different values that are passed in here are stored on chain, and then within that, there's a method of coming to consensus based on the input values. And yes, these are using smart contracts. All right, if you, in a nutshell, the average values from different sources, the values create consensus of the final value. Yes, except for not average, but median, just because it's a little more resistant to, you know, if you have the average being like, you know, if we have like 400, 399, 398, 1 billion, that'll really affect the average, but the median price won't be affected by those outliers as much. So what does Chainlink offer? The three big things that we're going to talk about today are data feeds, VRF, and keepers. Data feeds, as the name says, is essentially getting data on chain, off-chain data on chain. VRF stands for verifiable randomness function. I like to just think about it as random numbers that are provably random. And then keepers are a method to automate smart contracts. And then let's dive into data feeds. So data feeds are a way of accessing that off-chain data. You know, this could be anything from market data, whether that's pricing of different assets. That's probably the biggest use case right now that we have, is the asset pair valuation. And when I say asset pair, what I mean by that is, you know, if you have like Ethereum in terms of USD or Bitcoin in terms of Ethereum, that kind of asset pairing like that. You can access literally any web API through a product called Any API and bring any off-chain data on-chain through that. So these data feeds for bringing the asset pair pricing on-chain are used by projects like Aave, SushiSwap, Synthetics, and Compound to power the DeFi applications that they have spun up, and they give them reliable price data for their different feeds. There was a question just a few moments ago about how this works. And I think that this chart, while it's a little bit busy, explains it pretty well. Starting over on the left, we have our different exchanges, right? So those are going to be, you know, the actual prices that things are trading at the moment. The data providers get information from the exchange. The Chainlink nodes get their information from those data providers. And so the different nodes will have, they're all run by independent operators, and they will use different data providers to get their pricing information. The Chainlink nodes then submit their pricing information to the reference contracts, which are aggregators. So they aggregate all that information together. And then you can use those reference contracts to get the pricing data on chain. So that's kind of like the flow of information through the system. So if you head on over to data.chain.link, you can actually see what this looks like and see some of the different oracles who are providing this information. So if we head to data.chain.link, you can see here we have some of the different feeds. We'll just take a look at the ETHUSD feed. So here we have a few different things to talk about on this page. The first is this trusted answer. So this is going to be that aggregate answer for the price of this asset pair. And to answer the question of how often the pricing data is updated, it depends. What does it depend on? The trigger parameters. So the first is this deviation threshold. These oracles are submitting their data constantly to the contract. And the contract will update this trusted answer if either of these trigger parameters is met. The first is this deviation threshold. That means if the price changes, in this case, by 0.5%, it will update the trusted answer. The other trigger parameter is going to be the heartbeat. So essentially on a time basis, if it hasn't deviated, more than 0.5% in this case, then I believe it's about within an hour, it will update this one. You can look and see as updated 2 minutes ago, and the heartbeat is got about 58 minutes left. So update frequency depends. Man, y'all are like asking the questions in perfect order of what I'm going to talk about. Like, I'm really proud of you. This is amazing. So who pays for this? We'll get to that in 1 second. The oracles that are reporting for this one. So in this case, we need there to be at least 21 different oracles reporting a price. Currently, there's 31 out of 31. Who are they? You can see here the different oracles. I don't know if you may recognize some of these logos, but all of these different oracles are reporting their prices. And you can see there is some variation in the price, right? We have 1647 versus 1649, right? And we can see that the actual answer is somewhere in between those. You can take a look at the answer history, so you can kind of look and see what the price has done. And then you can look and see more information about the different oracles, who they are, what they've responded, and stuff like that. So when it comes to paying for this, one thing to know is that using the price feed doesn't cost anything, right? So when we have a blockchain, there's two main like categories of function. And I don't know if you all have used Remix, for example, but in Remix, there's two different colors of buttons, and we'll see those in the demo. One is orange, and orange buttons in Remix cause a state change on the blockchain. What that means is you're actually changing data on the blockchain. These are functions that cost gas. The other type is more of a query function where you're just reading data from the blockchain. That doesn't cost any gas. So you can use the price feeds without paying for it. Sounds great, right? Why would anybody pay for this? Who pays for this then? Because it costs money to update this price feed. Who pays for this? Well, if you scroll all the way down past all the different oracles, you'll see some of the users. And I kind of like to think of them as sponsors. These are people who are using this price feed and are essentially paying for it because they have created an application that relies on this price feed. So they need it to be there, right? If the data is not reliable or not consistently available, that's going to be a huge problem if you are someone like Synthetics, for example. And they are incentivized to incentivize the oracles to report this data. So that's kind of how it works from a who pays for it side of things. There was a couple other questions here. We answered how often they're updated, who pays for it. We just talked about that. How secure is the network from malicious nodes? There are only 31 nodes. Could I just add 32 nodes to manipulate the price feed? So in theory, yes, you definitely could, right? You could spin up 32 nodes, but the nodes also have a history and their pricing history, like the prices they report, that history is in there so that you can kind of audit how reliable the node is, just as a kind of safeguard there. Median price from 31 nodes is reported. Yes, that's correct, Jack. Okay, so we've talked about data feeds and the price feeds within data feeds. All right, and we can take a look. I can show you where any API is that would allow you not just to think in terms of price, but of literally any API. And we'll take a look at that in the docs in just a moment, any API. But before we get into that, let's talk about VRF. So VRF, again, that's verifiable randomness function, random number generators. That's what I like to think of. And it creates a method of generating a provably random number on the blockchain. And a very important part of that is a random number on the blockchain. So a lot of times in demos, you can generate a random number within a smart contract by using like a hashing algorithm and some sort of seed that is in theory random. And the reason I put random in quotes is because a lot of times what's used is something like the block hash, right? Where like the current block's hash, that's what's the seed. You can't know that beforehand, right? In theory, like what's going to happen. But there is a slight problem with random numbers generated this way. And if we kind of take a look here, we're over here in this user interface on the right-hand side, and we have just a basic contract here where we're just going to be flipping a coin, heads or tails, right? And randomly, we're going to generate a heads or tails response. Our smart contract has that. It's going to use the block hash. But the miners of that block, they can see what the outcome of the coin flip is going to be before the coin is flipped on the blockchain. So before they actually mine that block, they can know what the outcome is going to be, and they can choose to include or not include that function in the block. This is a problem. You could end up with essentially the ability to re-roll or reflip the coin until you get the outcome you want. So while the outcome is random, you get to pick which outcome you actually put. And that is not good when it comes to projects that need, actual provably random numbers. This is especially true when there's, monetary value included. If we're just, flipping a coin for fun between friends and just keeping tally, maybe not so important. But when you have projects like Pool Together, which is a lottery system, it becomes a lot more important. Also, you have NFTs with random traits like Avagachi, and there as well, it can be really important to make sure that they're actually random because, again, there are monetary incentives to some of the traits. So random numbers, randomness, also very, very important to make sure you have that in a method that is provably random. When I say provably random, what I mean by that is when the number is submitted to the blockchain from the Oracle network, it submits a mathematical proof showing like how it was generated. And so you can verify that, yes, this actually was a random number, which is awesome. Lots of different uses for that. I think that's like, I'm always surprised when I see how people are using random numbers outside of like, just the general raffle and random traits for NFTs. But before we jump into keepers, any questions about VRF? Okay, I'm going to keep going along then. The last thing.
Hand raised from.
I want to ask a question.
Yeah, go ahead.
Okay, so yeah, I tried using Chainlink VRF for a practice project, and so basically, what I did was I tried to request like 7 random numbers in one request. Like Chainlink gives you the option to request multiple random numbers, right? So how do you ensure that those 7 numbers in that array are unique themselves? They won't be repeated in the same array. How do you ensure that?
So I've talked to the engineering team about this, and like technically, because they are random numbers, there is the chance that they could have a repeat because each number is random, but I forget what the odds are of it. Like if you've seen like the size of the random number, like, I mean, the odds of that happening are infinitesimally small. Just because of, like the fact that they are actually random numbers, but given that they are random numbers, you could have that sort of thing.
Yeah,
I think it's similar to like there is, I believe, a possibility that you could have a collision of like Ethereum wallet addresses, right? But it's like the chances of that are like there's like less atoms in the universe than there are like odds of you doing that kind of thing. So it's, it technically a possibility, but no.
Yeah, I mean, there could be also a simple check, like if in the same array there's like one random number, you can check, that the next random number is not the same as the previous one. something like that.
Yeah. Yeah, you could double check too, for sure.
Yeah.
And because a lot of times too, what will happen is you'll use, because the random numbers that come back, they're very large. You'll use some sort of like modulo operation to take them down to a smaller number, because you're not going to have like however many million or 100,000 traits. So then you could check for that. But yeah, no, it's a possibility, but it's very, very unlikely.
Yeah. Thanks for answering.
Yeah, sure. So moving on to Chainlink keepers, smart contracts. We talked about their power. We talked about their transparency. We didn't talk about how lazy they are. Smart contracts, sorry to say it, don't do anything by themselves. And what that means is they need some sort of interaction. Something needs to execute a function for the smart contract to run. That's where something like Chainlink Keepers comes in. Chainlink Keepers, again, uses that distributed Oracle network to execute functions within smart contracts. So this means that you can develop your smart contract. You can add 2 functions to it to make it Keeper compatible. Then you can sign it up for Chainlink Keepers. And once you've let the Keeper network know about it, they will take care of running it on whatever sort of time frame or event frame you would like. What I mean by that is like you can have it check to see if there is, a value that's going to create a Boolean true or false, right? So if the price of whatever Ethereum reaches a certain level, then do something within the contract. And so Keepers allows you to use event-driven or time-driven methods in order to automate your smart contracts. And I think that's really huge because you can create, like even smarter smart contracts that actually will do stuff on their own. You just like set them and off they go. And I think that's huge. Personally, like I love using Keepers just to kind of like set stuff. You could set it to make sure that a contract always has a proper balance if the contract is doing something where it needs a balance of some sort of token, stuff like that. I think that's amazing. We had a couple questions, I think, before we get into the demos. And do you have any questions as well on Keepers? I saw somebody ask if we would be doing a VRF demo. I don't know, Danny, time-wise, is it just 15 minutes left?
If you want to go a little bit over, do another
Okay.
demo, you are more than welcome to.
Okay, I can cruise through 2 demos if y'all want to do that.
Good.
And we can do data feeds and we can do VRF as well. And I'm just going to tell you all right now, my demos, it's basically just walking through the docs because Chainlink docs are the best. I might be biased though. Any questions on Keepers before we dive into the demos? No? Cool. Okay. Well, let's head over to docs.chain.link. And if you want to follow along, feel free. I'll try to go at a pace that's, good for following along. Question about the cost for Keepers. That is going to be dependent on what you're doing with them. So within the Chainlink ecosystem, there's the link token, and dependent on the gas fees underneath on whatever specific chain you're on is going to be kind of determinant of how much things will cost in terms of link. So when it comes to how much does Keepers cost, if you're doing something that doesn't have a very high gas cost within your contract, then the cost will be lower. If you're doing something that's, fairly gas intensive, a lot of computation within the blockchain for that function to run, then the Keepers cost will be higher. So it depends kind of answer. Can I get data such as measurement of global climate change from Chainlink? So this connect any API, we're not really going to go into that too much in this talk, but that's where you'd go. Like if you have a data source for that data, you can pull that into the blockchain. So the answer to that question is yes, as long as you have some sort of data source for it. Okay, so let's take a look at data feeds. We'll start there. Let me go back real quick. These 2 blockchains, we have EVM blockchains and Solana. I don't know if y'all have messed with Solana much, but compared to all of the EVM-based chains, it's a completely different animal. It's awesome, but it's just things are very different there. And so our documentation is different there. For all of the EVM chains like Arbitrum, Ethereum, Polygon, etc., the docs can be found over here. So if we go to data feeds, and size-wise, this is good for everybody. You can read it. Cool. So if we head to data feeds, you can read about data feeds, learn all about them, how they work. I'm going to head to using data feeds. And if we scroll down just a little bit, we'll see an example contract. Cool. This is an entire smart contract that will use data feeds to return the latest price of Ethereum in terms of USD. And let me get my wallet up. Make sure I get on Rinkeby because the documentation currently uses the Rinkeby test network. So you need to make sure you're on that. Things that will change as you change networks are things like the addresses, right? So the aggregator interface address will be different across different networks. In this example, in the VRF example, we'll see some other addresses that will change depending on what network you're on. So all of our documentation, it says, what network it's using. This one's Rinkeby. And so we have this example here. We could copy it, we could paste it, or we could click this open in Remix button. Remix is amazing. If you haven't used it, it's a web-based IDE for Solidity contracts, and it is one of my favorite tools in the space because it just makes life so easy. So we head to Remix. It's populated with that contract already. On the left-hand side here, you'll see this kind of Solidity logo here for the compiler. If you don't have a green check here, there's two ways to see if you have a green check. You can either click auto compile, which means every time you make a change over here, you will get a recompilation of your code, or you can click compile. Now, we want to deploy this to the blockchain. So we head down here to the deploy and run transaction. We need to make sure that we're using our injected provider. That's going to take the information from MetaMask, inject it into Remix so that we can actually interact with the blockchain. And then we're going to click deploy. Whoop. Got to make sure, man, bit me. I always get bit by that. You got to make sure you pick the right contract. So this contract imports a aggregator interface contract, and that's what it was trying to deploy. So price consumer v3 is the contract that we want to deploy. So we'll deploy that. It'll ask us to confirm it. And then we will practice our patience skills. Parents always told me it was important to be patient. Now I get to practice that every day as I wait for the blockchain. All right, we've got it deployed. We've got our contract here. And we have get latest price. Now, what does all this mean, right? We deployed a contract. What did we do? Let's take a look at the contract. Because just clicking buttons and not knowing what you're doing is a very dangerous thing. So the first thing we see here is we import that aggregator interface. That's going to be one of the Chainlink contracts. That's going to be that interface for the aggregation of the different values that the nodes have reported to the contract. Then we go ahead and set up this price feed as an aggregator interface within our price consumer v3 contract. We have some notes about what this stuff is. It's on Rinkeby, it's ETHUSD, and here's the address. We have our constructor. Within a smart contract, the constructor runs when you deploy the contract. So this code basically will only ever run one time, and it's going to set stuff up for us. In this case, it's going to set price feed to be the interface of the address of that interface on the Rinkeby network. And then we create this function called get latest price. We'll see a couple of things here. It's public. That means anybody can call it. And it's a view, which means it's not actually going to cost us any gas to run. If you notice over here, it's the kind of bluish color button. Those are ones that don't cost gas within Remix. When we deployed, we clicked an orange button. That cost us some gas. The get latest price function, it's going to use price feed. That's our aggregator interface, and get the latest round data. So that's going to be the data from the latest update to that price feed. Now, there are all of these commented out values in here. And these are in here to kind of illustrate what is there that we're not using. Solidity is very weird in that you have to include the space for all the values that are returned from this latest round data function, but you don't have to like name them anything. So, you know, we have the round ID, the price, that's what we're actually interested in. When the round started, the timestamp of the round, and the answered in round, so what round it was answered in. And so the like absolute proper way to do this in Solidity would just be, and this is why these are here, like if you ever see this, it's the weirdest looking stuff. So let me clean this up so it's like, you know, proper, but this is what the function would actually look like. And I think that that's just like not very friendly. And so we have all those comments in there to say, you know, what is going to be in there that we're not actually using. And then we return that price, right? So from the latest round data, we get a price and we return that price. And that's what get latest price does. So when we click this button, we can see that the price of ETH in USD, man, it's going up super far, right? Like that's a huge number, except there's no decimals in there. And if we look at the price feed, right, we'll see there's a decimal place. Interesting. And it's about 1600. Right? So what happens is Solidity doesn't have the concept of decimal places. So we kind of artificially inflate the price, knowing that we're going to put a decimal in there when we're actually using it. So where does the decimal go? It goes 1, 2, 3, 4, 5, 6, 7, 8 places in. So our actual price is about $1,600. Cool. So that is the price feed contract, fully deployed and usable. Like we deployed it to the Rinkeby chain. You could have deployed it to the Ethereum mainnet if you wanted to spend real money. The question of 8 decimals. So 8 decimals is used for fiat price pairs, and 16 decimals is used for crypto to crypto price pairs. As to why, I think that's just like the kind of like standard accuracy that's used. There's a couple other questions though. If you have any questions about this contract, let me know. After this, we'll take a look at VRF and go through that real quick. So where did I leave off? From which location, where do we import? So where is this importing from? This is importing, it's essentially like NPM import. So Remix will download the contract and import it for you. If you look here, where's it at? It's under artifacts. Nope. Here where it is in here. Somewhere in here it grabs. Yeah, here we go. Yeah. So it's under this dependencies directory. We get the contracts in here. Down in here, there it is right there. So this is the actual contract that it's importing, and Remix went ahead and pulled that in for us. Okay, y'all are talking about that, answering that. Depends on the heartbeat and the price movement. Yes, so round data it will be updated based upon the update settings here for the parameters to trigger an update. Y'all got it. Cool. Okay, any questions about this before we pop on over to VRF? So we head back to docs.chain.link and go to randomness, VRF. And again, you can read all about it, learn all about it, watch a sweet video, all that cool stuff. Right now, we're just going to be concerned with getting a random number. So if we head here, we can take a look and see what all we need, all this cool stuff. And we've got our open and remix button right here, but we skipped over a lot of interesting things that we actually need to read this time because VRF works a little bit different than just reading data from data feeds. So VRF uses a concept that we call subscriptions. Essentially what subscriptions are is a way to create a bucket of link tokens and authorize various contracts to use that bucket of link tokens. So both VRF and keepers have a subscription interface. And before you create your subscription, you'll need to make sure you have some link tokens on the testnet. If you head over to faucets.chain.link, you can get some there. You will need to connect your wallet. My wallet was already connected, so we didn't see that little pop-up, but it will look at the network you're currently on in your wallet, populate your address. You can ask for sometimes some testnet ETH, as well as link tokens. Hopefully none of you are robots. If you are, congratulations on sentience. And you'll need to prove that you're not a robot. And then you can get your test link. So if you're following along, faucets.chain.link, get some test link on the Rinkeby testnet, and we'll head back to the docs. So we got that. We need to go to the subscription manager. So the subscription manager for VRF is at vrf.chain.link. And we'll need to create a subscription. It will give you the address for the admin. It's going to be your wallet address. You'll need to approve the creation of the subscription. And you'll wait for the confirmation of that. Yeah, add some like Jeopardy music while we're waiting on transactions. While we wait for this to go, we'll head back to the docs. So once we've got the subscription up, we'll need to add some link tokens to it. And then we'll need to add a consumer. And a consumer that's going to be the address of the contract that's going to get the random numbers. But we don't have that yet, right? So first, we'll need to actually create that contract. So we'll click on Open on Remix for the VRF v2 compatible contract. And this one is a lot more involved. Oh my goodness. So we'll dig into this once we finish this. So now we'll need to add some funds. We'll just say, sure, 10 link. 5, I think, would be plenty as well, but we'll just go for 10. Okay, so we've got that in our subscription ID. It looks like is 9700, but we'll wait for this to finish because we're going to need that ID number before we go on in Remix. This is close. Okay. So you'll notice now it's going to ask us to add a consumer, right? But this is kind of like we're at the chicken and the egg problem here of like which one comes first, because we don't have our consumer address. So we need to go make that. But we'll need this subscription ID. Yours will be different if you're following along. Okay, so back in Remix, let's walk through this contract, understand what's going on. First thing, we're importing in the VRF coordinator interface and consumer contracts. Coordinator, that's going to be what basically reaches out to the Oracle network, says, hey, we've got a request for a random number, and the Oracle network replies back with that random number. The consumer is going to be what this contract is. You'll see we have a few variables here. We have the subscription ID. That's going to be our subscription ID. We'll fill that in when we deploy the contract. Whoops. We have the address of the VRF coordinator. So this is going to be the contract that's acting as that coordinator, as well as a key hash for the gas lane. This is going to kind of determine which gas lane we're in as far as like speed. For the test networks, I believe there's only one. For the production networks, there are different ones. There was a question about how expensive keepers are. VRF also has the same kind of question in my mind, because when the random number comes back to the contract, you often want to do something with it. And so depending on what you want to do, you might need to increase your gas limit. You can kind of discover what you need your gas limit to be by looking at how much it costs to execute the functions that you're going to have called within your fulfill randomness function. We'll take a look at that in a second. We have request confirmations. This is how many block confirmations need to go by before the random number is returned. On Ethereum, I believe it's 3 is the lowest. I know that on Avalanche, for example, we have 1 as the lowest, so it's a lot faster, but less secure. So the higher this number is, the more secure the random number is. The lower it is, the faster it is. There was a question earlier about getting more than one word back. So in this case, we're going to get 2 random values. Sorry, I said word, and we need to talk about that, but 2 random numbers. We use the term words within our contracts. And if you want to go down like a Wikipedia rabbit hole, understanding what words means in a computer science context, I welcome you to do that. But essentially, this is like the computer science proper term for values. And so they're called words. In my mind, I just translate words to numbers. That sounds really weird, but yes, like, when I see number of words, I just think, how many random values am I getting back? We have a array to store those random values. We have our request ID. That's going to be like when we make a request for random values, we'll store that ID. The owner of the contract, and then we have the constructor. So the constructor, again, is run the first time when the contract is deployed. What it does is it's going to set up the coordinator, the owner, and the subscription ID, and we'll actually pass that ID in when we deploy it. You'll see that there's actually a spot to pass in a subscription ID, and that's going to be that value that we saw on the other screen. So we're just kind of setting up some variables when we deploy. Within here, there are 3 functions, only really 2 that we care about, but we have only owner that just makes sure that, some of the functions can only be run by the person who deployed the contract, the owner of the contract. The first function is request random words. This is where we reach out to the coordinator and we say, hey, we'd like a set of random numbers, please. And we pass through, like the key hash and the subscription ID, how many confirmations, essentially all of the variables that we set up above. And we get our request ID back, and then we wait. And what happens is that coordinator goes and gets the random values, and then it will come back and call the fulfill random words function in this contract. So the coordinator essentially comes back with that and calls this. And you see here, it can accept in the request ID, and it can also, then it also passes in those random values in an array. We are not really concerned about the request ID here. But if you were doing something where you had like multiple things calling random, like requesting random words, then you'd want to keep track of that, right? Like if you had minting an NFT, for example, every time an NFT is mint, you'd need to kind of tie the NFT ID to the request ID so that when it came back, you know which NFT to update. So we'll store those random words and then we can view them because this is a value that we can take a look at. Okay, so that was a lot. But before we do anything else, we need to go and get our subscription ID again. Okay, and we'll come back here and we'll deploy this with that subscription ID. But we got to deploy it to an actual blockchain, not to the test one. And make sure that we pick the right contract. There we go. Confirm. We got a couple questions here. Would you have a flowchart to review the subscription ID owner and coordinators? Any drawings to better visualize this flow? I don't know if we have that offhand. I haven't seen that. I don't think there's anything in here that does what you're asking. But that would be a smart thing to have for sure. I don't think that we have that. I'm sorry. Okay, so we have deployed this and we gave it the subscription ID. We now need to get the contract address, right? And we need to essentially authorize it as a consumer. So put in our contract address here, add the consumer. Once again, we need to confirm. Is it possible to test a VRF-based contract on Remix? I think that's what we're doing right now. If you mean something other than what we're about to do, let me know. So we deployed it with the subscription ID, and then we got the contract address, came back over here to the subscription, authorized it to be a consumer. We can, we can take a look. Why? Maybe we can take a look. Oh, weird. Okay, well, that's fun. I don't know what happened to my subscription. Maybe I timed out because I took too long to create it or something weird. Let me just deploy it again with another subscription real quick. I think it probably sat there for too long and it didn't let me create my subscription. Okay, so this contract, and then we'll grab address and we'll come back here and we'll add a consumer. Okie dokie. And once we have this confirmed, we can go get a random number. All right, so we've got that. You can kind of see here, this one, I obviously have other consumers have added to it. We have the history of all the different requests that these consumers have made. But if I come in here and say, hey, I'd like to request randomness, please. It'll go off and it now talks to that subscription. And so we can come back here. And if we refresh this page, in just a moment, once that's confirmed and all the way through, we should see a request that comes in here. Maybe, unless things are slow. Okay, so it's confirmed there. There's a question about the key hash gas price. Those are here. They were kind of already put in the contract for us. So in the example, they're kind of up at the top. So if we take a look here, we should see a request come in. And then we've got our request ID. Okay. I don't know why it's not showing up. Or something's going on. What's this address? 2A4. Oh. Yeah, I think something's going on with this front end today. I wonder if they're doing a change that I'm not aware of. But normally you would see a yellow dot here while the request is actually in the process of being fulfilled. And then when it's successful, you get the green dot. And if it wasn't successful, you'd get a red dot, which, oh, this one doesn't have any. I get red dots all the time. Normally, because I have the callback gas limit too low for the function I'm trying to do within my contract. So that's something that you can definitely run into if your fulfill randomness, this fulfill random words, is doing something that's more gas intensive than your limits, like it'll fail. So let's see if we have random words yet. We do. Okay, so I'm not sure what's going on with the front end, but our contract has gotten a random number, come back and fulfilled that random number here. This 0 is because we have a array of random numbers, and arrays start counting as 0. So we have two values in there, 0 and 1. So if we take a look at 1, which would be the second value, you'll see it's a different random number. So we requested 2 random numbers. If we had changed this to be, like 20, we would have gotten 20 different random numbers. So this is how you can get different random numbers that are provably random within your smart contract as well. I don't know, the docs, like, I love the fact that you can just click a button and deploy to Remix, and it's, I don't know, that easy. But those are the 2 demos. We have a Discord, we have our documentation, we have starter kits that will, if you want to use something a little bit more involved than Remix, like Hard Hat or Foundry, or any of the other ones that we have, Brownie out there, you can do that. They kind of give you everything you need to get started with smart contract development using Chainlink stuff, as well as the Chainlink Academy to learn more about blockchains and smart contracts. Do y'all have any questions for me? or should we call it a session? We have a question. I see a hand.
Yes, let's get those final questions answered. So if you want to go ahead and unmute yourself.
Yeah, so I have a question, or more like a suggestion. So I've been looking into the Chainlink VRF, and it like, it's not as straightforward as calling a function and getting a random number. There is some complexity involved, some variables involved, like key hash, gas fees, and stuff like that. So I think it could be simplified to a huge extent if the pricing model was just a bit different, because right now you have to pay the price in link. So when I first came to know about Chainlink VRF, and I came to know that you have to pay a certain price in link points to get a random number, and that price can actually change based on the current gas fees of the blockchain, and also a couple of other factors. So I think it would have been much easier for consumers to actually, if there was like a price in stable coins, you already know, okay, this is the price for getting a random number, for getting 7 random numbers. Okay, this is this high than getting 1 random number. So like, it's predictable, you know what you're getting in. You won't get shocked after you use Chainlink VRF that, oh my god, okay, why is the price suddenly so high? Because the link tokens price is also constantly changing. It's not stable, right? And the gas fees on the blockchain is also variable. It keeps changing. So it would have been, it would be much easier for, as a customer, as a consumer, to have the price in a stable coin, like maybe USD Tether or something like that, or maybe Chainlink's own stable coin in the future, something like that.
Okay. Yeah, no, I appreciate that feedback, and I'll pass that on.
Thank you.
There was one question I saw about keepers. I don't think we have time today to go through a demo of that, but it's kind of the same. If you go to docs.chain.link and you go to automate contracts, this will walk you through it. Essentially, keepers, you need 2 functions. You need a check upkeep function, which returns a Boolean, and then a perform upkeep function, which if that Boolean is true, then the keeper's network comes back in and calls that function and basically does whatever automation function you want. There are examples here. This example shows like just kind of incrementing a counter. Trying to think what the fastest way to get this link is. I also have a, let me grab a YouTube and I'll pop it in the chat real quick. Where I made like a dynamic NFT that uses keepers. That will walk through using VRF keepers to automate like a NFT changing dynamically. Cool. Any other questions? We got hand raised. Sebastian?
Yeah. Hi. I have a question related to user cases on keepers. So what are the usual user cases, basically?
Yeah, so I don't know if usual ones. I'll just speak to like examples I've heard of. So there are updating things based on stuff like weather, things like that. For sure, the time-based aspect of it as well, like to create like a regular heartbeat of change for different contracts. Definitely, I know that there are several projects out there that use keepers to automate checking balances in order to ensure that contracts have a proper balance of whatever token they need. Before we had the subscriptions model for Chainlink, we could have multiple contracts using one kind of bucket of link. There was the idea where each individual contract needed to have link, and so people would use keepers to ensure that their contracts were funded from that aspect. So I guess anytime you think, man, I need to go check this thing and click, click run this function. That's where Keepers comes in. So I don't know if there's like a usual use case, but those are some of the ones I've seen, if that helps.
So automation, basically.
Yeah, anytime that like you would run a function and like you want to do it like when something happens or on a certain time frame, yes. Like if you're familiar with like Unix, Linux, like think of it like cron.
Awesome.
And then like
Thank you.
plus because you can have it like actually check things before it runs. Appreciate y'all hanging in there, and I appreciate the questions and interactivity. It makes it a lot more fun for me.
Awesome. Well, yeah, it looks like there's no more questions that you see, Richard. We can go ahead and wrap up here. So yeah, thank you for the great session. And again, I apologize everyone for a few technical difficulties we hear at the beginning of this session, but everything still went great. And thank you for the kind of the very active questions in the chat, and Richard for getting them all answered. So looking forward, I posted my emails with my Twitter in the chat there, as well as the Encode Club Discord in the registration form. So please do reach out to myself if you have any questions regarding the hackathon or want to hop onto a call. I'm always happy to, and kind of give some recommendations on projects, or kind of just assist with any questions about the hackathon in general. Looking forward, we will be making an announcement in the Discord channel regarding the next workshop, which will be an ideation workshop. And as I mentioned earlier, if you do want to go ahead and rewatch this online, we'll post the summary, the slides, and the video on YouTube and Medium by tomorrow. So you'd be more than welcome to check those out. And yeah, if any questions do come up in the meantime, go ahead and check out the Discord channel, ask any technical questions, or kind of introduce yourself in the club room. You're always more than welcome to. But yeah, nothing else here. So again, Richard, thank you so much for the amazing workshop again. And everyone have a great rest of your day, evening, night, wherever you're located.
Yeah, appreciate it. If you have any questions, feel free to reach out on Twitter to me.
Yep,
well.
and I'll post that in the chat as well.
Yeah.
So go ahead and connect. Awesome. Well, see you everyone. Have a great rest of your days.